I'm Minori. I'm a third year finance student and a triple minor in sustainability, environmental studies, and studio art. And I am a SLURP intern, as Kristen mentioned, which is basically means that I'm interning with the Center for Sustainability um, at Santa Clara University. And I'm going to be introducing our next speaker, Dana Nucciatelli, sorry. He's an environmental scientist, an author of Climatology versus Pseudoscience. He has published 10 papers related to climate change in peer-reviewed journals, including 3 studies on the expert climate consensus. Nucciatelli has written about climate science for skepticalscience.com since 2010, for The Guardian since 2013, and for Yale Climate Connection since 2018. And now he will be talking about wildfire science. Yeah, I'm really excited.
So this slide just quickly summarizes my background again. So I have been writing about climate change for a little over a decade. Started with Skeptical Science, which is a really good climate science myth debunking website run by a team of international volunteers. Then in 2013, I was hired by The Guardian, where I wrote for them until 2018, a little over 5 years. At which point I joined a group at Yale called Yale Climate Connections, who I'm still writing for now. 2016, the National Center for Science Education gave me the Friends of the Earth Award for that writing. Written some peer-reviewed climate science papers, the book Climatology versus Pseudoscience, and I'm a member of this group, Citizens Climate Lobby, grassroots climate advocacy group, CCL. I'm in the Sacramento chapter, and I'm also the CCL National Science Team Lead. Okay, so let's get into the good stuff. So I'm sure we all agree California is an awesome place. We've got beaches, we've got mountains and snow, we've got forests, we've got the valley with great agriculture and food. But with that diversity of geography, we've also got a diversity of climate change impacts. So along the coast, we have to worry about sea level rise. In the mountains, we have to worry about the snowpack shrinking, which has been a real problem. So far, we've lost about a quarter of the Sierra snowpack to increasing temperatures. And this year is particularly bad. I think we're at around 40% of normal snowpack right now. In the valley where I am, we have to worry about heat and drought. I'm probably going to be talking about drought a lot more this year because we're heading into a really bad one. And then there's wildfires in the forests and scrubland, which we're going to talk about today because that's kind of been the most direct impact that we've been feeling in California in the last few years. So I'm going to spend about the first half of the talk talking about climate change and wildfires, and then the second half I want to focus on solutions because that's really the important stuff. But let's start with the wildfires. So this is a chart of the 20 largest wildfires on record in California from CAL FIRE. And if you look at it, you'll see a pattern that the first, third, fifth, sixth, and 18th largest wildfires on record in California were all ignited at basically the same time last August. And then the fourth largest wildfire was ignited the next month in September. So 5 of the 6 largest wildfires on record in California happened last year, which is pretty crazy. And then the largest wildfire was our first mega fire, the first one that was over 1,000 acres, more than double the previous record largest wildfire. So it was really just a crazy, crazy wildfire season last year. So we're going to talk about what happened to create that season. So this chart is again CAL FIRE data looking at annual acreage burned by wildfires in California from 1987. Which is when that's when the good records start because we have satellites with cameras on them at that point up through last year, except you can see this last bar is a little different. It's actually only a 5-day period last September, whereas all these other bars are the entire year's wildfire season. So you can see just those 5 days last September, over 1 million acres burned in California, whereas the average annual acreage burned from 1987 to 2019 was about 500,000 acres. So there was a 5-day period last year when we basically had 2 entire years worth of acreage burned, which is pretty crazy. It was more acreage burned during those 5 days than 28 of the previous 33 entire years. And of course, that was just 5 days. So if you look at the entire wildfire season, it looks like this. So it was about 4.2 million acres burned in California. A previous record was set just 2 years earlier in 2018, a little under 2 million acres. So last year broke the record by more than a factor of two, more than double the previous record, which was set just 2 years ago. This line is the long-term trend in the acreage burned. You can see there's a lot of variation up and down year to year because some years happen to have wetter and cooler weather, some years have hotter and drier weather. But overall, wildfires are getting bigger and bigger over time in California. So let's zoom in on last summer and see what happened to ignite all those record large wildfires. And it was basically like a perfect storm of events. So one thing that was going on, you might recall, we had this thing called a heat dome sitting over the southwestern United States, including California, which is basically like a high pressure system holding air, in this case, hot air, in one spot, and it just wouldn't move. And so it was basically sitting there for the entire month of August, holding this hot air in place. And so you may recall, if you were around in California in August, we were having these record high temperatures. Where I am in Sacramento, we were having 100+ degree days for like entire weeks on end, just terrible, terrible heat waves. And so as a result of, in part because of this heat dome, it was California's hottest August on record. So this chart is from NOAA, showing California's temperature every August from 1895 till last year. You can see last year is way up here, more than a degree Fahrenheit hotter than the previous hottest August in California. Pretty much the same thing happened in September. This is California's temperatures in September since 1895. And again, there's 2020, way above all the rest, a degree Fahrenheit hotter than the previous record. So basically we had 2 consecutive record-breaking hot months, in large part because of that heat dome and also the long-term trend of global warming. At the same time as that was happening, this is an image from mid-August. This tropical storm Fausto, off the coast of Baja California. So you recall the heat dome was sitting right here. And what happened was that the heat dome basically sucked in moisture from this tropical storm. And the result was, you may recall, we had a whole bunch of lightning storms. We had 3 days. This is a nice image from, again, mid-August. And you can find a lot of these if you just Google like August 2020 California lightning strikes. There's tons of these great photos because there were so many lightning strikes. There was more than 11,000 lightning strikes over a 3-day period across California. And because it was happening in the middle of summer during this intense heat wave, it was super hot. So any precipitation falling from these clouds evaporated before it hit the ground. And so these were dry lightning strikes. And so you have 11,000 lightning strikes hitting the ground in the middle of summer when it's super dry. It's record heat happening. And so it sparked a bunch of fires, sparked vegetation, igniting fires. And because it was so hot and dry, there was a lot of fuel, hot and dry vegetation available for these fires to spread really far, really fast. And so you just had a bunch of kind of explosive wildfires because of these factors combining of this really rare lightning storms and this intense heat in the middle of summer. So it was kind of a perfect coincidence of events for this to be a really bad wildfire season, which is why we saw 5 of the 6 largest wildfires on record in California last year. One consequence was all the smoke we were breathing. We had the worst air quality in the world. So this is a map of air quality measurements around the world. And I just chose mid-September because at that point, it was kind of the entire west coast of the United States, California, Oregon, Washington, Montana, Idaho. All these states were having just terrible, terrible air quality, the worst in the world, between very unhealthy and hazardous air conditions. And so I wrote again because actually it happens the very first piece I wrote for Yale Climate Connections in November of 2018 was about the then record wildfires in California and how they were causing California to have the worst air quality in the world. And then it just got kind of worse this year. And again, we have the worst air quality in the world as a result of these wildfires and the associated smoke and air pollution. And this map, the New York Times put it together from some data that was recently published of change in air pollution levels from 2019 to 2020. So basically a blue downward arrow means the air quality got better, improved between 2019 and 2020. And so you can see basically the entire eastern half of the United States is covered in these blue arrows. because of COVID restrictions, because people were stuck at home, they weren't driving as much, we were using less electricity in general, so we were burning less fossil fuels, and so air pollution decreased on the east half of the country from in 2020 as compared to the previous year. But on the western half of the country, it's the opposite story. You can see these really large arrows upward, showing that air quality was much, much worse in 2020 than 2019 because the wildfire pollution has really swamped out any improvement we would have seen due to these COVID restrictions. So yeah, it was just a really bad air quality year because of these record wildfires. And there was just earlier this month, this study published in Nature Communications looking at the public health effects of breathing different kinds of air pollution. And what they found was that when people are breathing smoke from wildfires, they basically have 5 times more hospitalizations than an equivalent amount of air pollution from other sources like fossil fuels, for example. So just because of all the stuff that's burning in wildfires, the air pollution is particularly bad for public health. And so it's a really harsh climate change consequence for California that we have these wildfires that then put all this smoke and this really nasty pollution into the air that we're stuck breathing. So let's zoom out and look more at the long term, what's causing this long-term upward trend in California's wildfires getting bigger and bigger. Unfortunately, like most issues in America these days, this has been politicized. So as the wildfires were burning last year, there was this segment on Tucker Carlson's Fox News show where they were talking about what's causing it. And you can see from the Chiron on the bottom that he's saying Democrats are blaming it on climate change. And then later in the segment, he says, we think it's due to forest mismanagement and the buildup of wood fuel. And I mean, this is the kind of thing that drives scientists crazy because there is like an objective reality based on scientific evidence where we can look at what's causing these things. And whether what you believe is the cause shouldn't boil down to whether you're a liberal or conservative. But unfortunately, that is more and more frequently the case. Just climate change itself, that's the case. There is polling showing that if you're liberal, you're more and more likely to, over time, to believe, to accept that humans are causing global warming. Whereas if you're a conservative, you're more and more likely to reject the reality that humans are causing global warming, even though the scientific evidence is increasingly overwhelming over time. And that's the kind of thing it drives scientists nuts. So in this case, it's actually both factors played a role. And so this is a chart from a nice paper published a few years ago looking at biomass burning in California, which is basically the amount of trees and other vegetation burning every year over the past 1,400 years. And so the gray line is the amount of biomass burning, and the red is smoothing it out. And so you can see this is the past 100 years or so. There's been this really steep decline in the amount of stuff burning every wildfire season. And this black dotted line is how much we expect to have burned based on the climate conditions, based on how hot and dry it is. And so because it's gotten so much hotter over the past 100 years because of global warming, we would actually expect an increase in the area burned by wildfires in California, whereas we actually saw this steep decrease. And so that difference they called the late 20th century fire deficit, which is a result of really just aggressive fire suppression tactics. Whenever there's been a wildfire over the past 100 years, we've just put it out as quickly as we could. And as a result of suppressing these natural wildfires, a whole bunch of vegetation that would otherwise have burned just built up and built up and built up. And now there's just a lot more material available to burn when there is a wildfire. And so that's, fire suppression, that's a type of forest management. And so that is definitely one contributing factor to why wildfires are getting worse in California. But it is not the only contributing factor. So there is a really nice report that Congress mandates is published every few years. It's called the National Climate Assessment Report. It's basically like America's version of the IPCC report. We get our best climate scientists to kind of summarize the latest and greatest climate science research as it pertains to the United States. And the last one they published was in 2018. And one of the things they looked at was why are wildfires in the Western United States getting worse over time? And they have this good quote summarizing their findings. The area burned by wildfire from 1984 to 2015 was twice what would have burned had climate change not occurred. The area burned over the past 200 years was more closely related to climate factors than to fire suppression, fire management, or other non-climate factors. And climate change is drying the forests and making them more susceptible to burning. So yes, fire management, fire suppression are contributing factors, but the single largest contributing factor is climate change, drying the forests and making them more susceptible to burning. And in that report, they have this nice chart. This is the cumulative area burned by wildfires in the Western United States every year. So you're adding up the area burned to the area burned in all the previous years, which is why it goes up every year. And so this yellow is the area that would have burned without climate change. And then the orange is the additional area that burned as a result of climate change. So as you can see, as that quote said, climate change doubled the area that would have otherwise burned had humans not been altering the climate and increasing temperatures. And then one issue is that California's wildfire season is getting longer and longer. And there was a really good study on this just last year. It happened to actually be published right when all these record wildfires were burning. And it's published by all these guys who are like experts in climate change and California wildfires. So it's kind of the top experts on this. So I was really excited to see this paper. And what they were looking at was this thing called the Fire Weather Index, which is basically how conducive the weather conditions are in a given day to bad wildfire. So basically how hot and dry and windy it is on a given day. And they're looking at the 95th percentile, which means the 5% worst days for wildfire conditions in a given year. So kind of your 5% hottest, driest, windiest days in a given year. And they're looking at how many of those days fall in the autumn months, September, October, November. And so if they go back to the 1980s, you can see there's very, very few of these extreme fire condition days because in the fall, in the 80s, it tended to be pretty cool and pretty wet. And so just we weren't having these really bad conditions for wildfires. But over time, there's been more and more and more of these extreme fall wildfire days, now more than twice as many as there used to be. And so they looked at what's causing these worse wildfire days in the autumn months. And they found two factors contributing to it. One is pretty simple. Global warming is making temperatures go up. So this is a chart again from NOAA of California's temperature in those fall months, September, October, November. And you can see we're about 3 degrees Fahrenheit hotter on average in those fall months than we used to be 120 years ago. So again, when it's hotter, everything gets drier and it's more conducive to wildfires getting worse. So that's one contributing factor. The second contributing factor is that California's rainy season is shifting. So this is a chart from another paper published a couple years ago from a meteorologist at UCLA, Daniel Swain. And so what we're looking at is this black dashed line across the middle is the average precipitation in each month in California before humans started altering the climate. And then the colored lines are current to future precipitation in each month. And so the kind of brownish, orangish, yellowish ones are Southern California, and then the greenish ones are Northern California. And so you can see in the fall and the winter months, all the colored lines are above the black dashed line, meaning we're actually getting more rain in the winter than we used to. But the opposite is happening in those fall months. All the lines are below the black lining, meaning we're actually getting less precipitation in the fall than we used to. And the same thing is happening in the spring. All the lines are down here, meaning we're getting less precipitation than we used to in the spring months. And so, California, we've got this Mediterranean climate where we basically don't get any precipitation in the summer naturally. And so what's happening is that because the rain is decreasing in the spring, the dry season is starting earlier than it used to. And because we're getting less rain in the fall, the rainy season is starting later, or the dry season is ending later than it used to. And so on both bookends of the dry season, it's getting longer and longer and longer, which means it's just drier and drier than it used to be in those September, October, November months. And so combination of hotter and drier just means a lot more wildfire fuel when a fire gets ignited. And in this paper, they use some language that you might be familiar with seeing from the US Department of Defense. They've been calling climate change a threat multiplier for a long time now. And in this paper, they called climate change a wildfire threat multiplier, amplifying natural and human risk factors that are already prevalent throughout California. So, we've already got the Mediterranean climate with the dry summer. We've already got human factors that ignite wildfires. So maybe power lines might go down. Maybe somebody in the middle of summer will decide to do a gender reveal party for their child that use some pyrotechnics and ignite a fire that way. And then because it's now hotter and drier than it used to be, that kind of amplifies those risks and spreads wildfires further and faster than they used to spread. So in this paper from last summer, they looked at projections of the future, how wildfires are going to, how these extreme wildfire days in the fall are going to increase over time. And so the left is Northern California, the right is Southern California. The blue is a scenario where we take some action to slow global warming and curb carbon emissions, whereas the red is if we keep burning lots of fossil fuels. So you can see in Northern California, there will be an increase in a continued increase in these extreme fall wildfire condition days because there's just going to be some additional global warming, but there's a pretty significant difference between taking action and kind of slowing that increase versus continuing to burn lots of fossil fuels and having that increase go up and up and up. So that, basically years like last year's wildfire season will become pretty commonplace if we don't solve the problem, whereas it'll remain relatively rare occurrences if we do take action. And they put this in a map form. So this left one is the blue scenario. It's if we limit global warming to 2.5 degrees Celsius, which you may be familiar with the Paris Agreement, trying to limit global warming to less than 2 degrees Celsius. So this scenario is like if we miss Paris, so we can do better than this, but this is if we miss Paris, but we still slow global warming somewhat. And then the right scenario is the red line. It's if we get to 4 degrees Celsius, which is like burning lots of fossil fuels, catastrophic kind of scenario. So you can see, and then the red is anywhere from like 14 plus days in the autumn of these extreme fire weather index conditions. So you can see on the right, there's a lot more red than on the left. So that means just a lot more really bad wildfires going into the September, October, November months, especially in the Sierra Nevada, very northern part of California, down by San Diego and LA. Whereas, again, in this left chart, there is still an increase, but it's it's a moderate increase. It's something that we can probably adapt to and live with. It's a scenario in which last year's wildfire season remains a relatively rare kind of occurrence. So, it's a good illustration that we still have control over just how bad our future conditions get, whether they'll remain manageable or whether they'll get really, really bad in the future. So now I want to shift to how we're going to get on that lower emissions path. So just kind of zooming out, this is kind of an encapsulation of the problem that we're facing in one chart. This is global greenhouse gas emissions, basically since pre-industrial times, 1850 through the present. So you can see there has been this long increase, especially after World War II in carbon dioxide emissions. So after World War II, economies started to boom. We started to use a lot more energy. We started to travel a lot more. So we started burning more and more fossil fuels. You can see there's this one little drop at the end, which is, of course, last year because of all these COVID restrictions, a lot of shutdowns of the economy. So there was a drop in about 6 to 7% of global greenhouse gas emissions last year, although we're expecting a rebound this year because, economies are starting to open back up and there's going to be more economic activity. So if we want to stay below the Paris targets, less than 2 degrees Celsius, there's a certain carbon budget that we have left. We can put a certain amount of carbon into the atmosphere and still stay below 2 degrees. And so if we want to do that, the path has to look something like this, where our emissions peak in the next few years and then they start to decline very, very steeply and get down to net zero somewhere in the ballpark of 2075 or so, give or take, various factors, including how steep this curve ends up being. So you can see this is a really big challenge. The slope, the rate at which this declines is actually faster than the rate at which we kind of built up all this fossil fuel energy use. So we kind of have to transition away from fossil fuels faster than we built them up. which is a big challenge. And then, I mean, again, that's for a 2 degree Celsius target. And there is also in the Paris Agreement a aspirational 1.5 degrees Celsius target, which looks something like this, where emissions have to peak very soon and go down even more steeply. So we get to net zero global emissions before 2050, probably, in order to stay below 1.5 degrees Celsius, because we're already at about 1.2 degrees Celsius or so at this point. So we're getting very close to 1.5 already. So this conveys the urgency of the problem, that we really have to peak our emissions very soon and then get them going downward, declining emissions very steeply, very fast. So how do we do that? I'm going to focus on policies in the United States because that's where we live, that's what we have control over. So one thing we can do is presidential executive orders, which President Biden did a whole bunch of these, including several really good climate executive orders as soon as he took office. So the kind of the limitation of executive orders is that they only apply to federal agencies and federal properties. So for example, President Biden said federal agencies have to get their electricity from clean sources. They have to shift their vehicle fleets to electric cars. The administration put a freeze on oil and gas leasing from federal lands. So these are all effective things, but they're very limited in scope because he can only control what the federal government does directly. So everything else is basically up to Congress on a federal level. So there's basically kind of two categories of approaches that Congress can take. One we call market-based approaches. So the idea there is that right now carbon pollution is free. So when you buy a gallon of gasoline, you're not paying for the cost of the carbon and the climate damages that carbon will cause down the line. That cost is borne by taxpayers, and we have to pay the cost of worse wildfires, worse droughts, hurricanes, floods, all these extreme weather. So the idea is that you put a price on carbon pollution to reflect that cost to society, so that polluters, industries have to pay for the entire cost of those fuels. So there's two main ways to do that. One is through cap and trade, which was actually originally invented by the George H.W. Bush, the first Bush administration, because they were facing this big problem of acid rain caused by sulfur dioxide pollution, another pollutant from burning fossil fuels. So the idea is that the government puts a cap on the total amount of pollution they're going to allow, and they sell permits for those bits of pollution to polluting industries. The industries then buy them. If they buy too many or they buy too few, they can trade them back and forth. So that's the cap and the trade part. And in California, we also have a carbon cap and trade system for climate change. So the challenge with cap and trade, so the nice thing is the cap gives you control. So over time, you can lower the cap and sell fewer and fewer and fewer pollution permits. So it's got very good control over the total amount of pollution. The downside is that it can be very complicated, and there can be ways to game the system with carbon offsets and things like that. And so people have we've started to kind of shift away from cap and trade toward instead carbon taxes, because it's much more simpler. It's not something that that industries can game. It's just like you pay for the amount of carbon in a given amount of oil, like a barrel of oil or a ton of coal. Like it's got a certain amount of carbon, and the polluting industry has to pay for that. And then the other type of approach that a lot of Democrats have been shifting to is kind of a combination of standards, investment, and justice. This is kind of the framework that the Green New Deal took. And so the idea is that you have a federal agency like the EPA regulate pollution sources. That's the standards. They set standards for how much industries can pollute. And then the investment, they invest in clean technology and research and deployments. And that's something that Congress has to do because they control the budget. And then the justice is that they want to address environmental justice in the process. Sometimes people question, like, why are you worrying about environmental justice when we had to solve this climate crisis, like, immediately? So I want to talk about that a little bit. So air pollution is really pervasive and really bad for public health. So globally, it's responsible for more than 30% of deaths. In the United States, we have relatively clean air, cleaner than places like India and China. And so it's less of an issue, but it's still 13% of deaths in the United States in 2018 were caused by air pollution. And then we have had this historic policy called redlining, where basically, as we kind of expanded out of cities and developed the suburbs, those areas were basically segregated so that only white people could live there. And so as a result, communities of color were segregated into cities next to these industrial pollution sources, highways, power plants, things like that. And so as a result of that, today communities of color are 79% more likely to be in a heavily polluted area than predominantly white communities. This stat blew my mind. In 2014, 2/3 of Black Americans were within 30 miles of a coal power plant, which is, as us in California with no coal power plants, it's a hard thing to fathom that so many Black Americans are stuck living so close to coal power plants. And the good news is that we have phased out a lot of coal power plants over the last 7 years, and so this number is going to have improved, but nevertheless, as a result, 71% of Black Americans live in counties that are in violation of air pollution standards, as compared to 58% of white Americans. Black children are much more likely to have asthma than white children as a result of breathing these pollution sources. And on average, Black Americans breathe 56% more pollution than they generate, whereas white Americans breathe 17% less pollution than they generate, again, based on where we have been slotted to live. So we've got this historical problem where we've kind of forced communities of color to live in these high pollution areas that are really adversely impacting their health, and it's been going on for a long time. So as we solve the climate problem, we also have to address this other problem that we've been burdening communities of color with for decades. So there's also an issue that climate change impacts are geographically distributed very differently. So this is a chart from a paper published a few years ago looking at some climate change impacts on local economies, on the economy of each county in the United States. And so you can see these red ones are the ones that have a very large adverse impact from climate change on their economy. And you can see they tend to be clustered in the southern states. So that's because one big adverse impact is hurricanes, and hurricanes are getting stronger. And so these Atlantic coast and Gulf Coast states are the ones being battered by worse and worse hurricanes. And another really bad climate change impact is heat waves. And the southern states tend to have very intense summer heat. And so when you have really high temperatures and it gets hotter, it has much more adverse impact on you than a relatively cool area that gets a little hotter. That's not such a big deal, like in the northern states. Like it's not, if you're already cool when it gets a little hotter, it's not a big impact on productivity. So we'll often hear that the United States is relatively not very vulnerable to climate change, but that's true on a whole. There's a very widespread, heterogeneous distribution of those impacts, where some regions, especially in the South, are actually quite vulnerable to climate change impacts. And then that same principle applies globally. So this, let's look at this bottom chart first. This is from a paper published 10 years ago, looking at the vulnerability of each region to climate change impacts, red being high vulnerability, blue being low vulnerability. So you can see the red areas tend to be in these countries like Africa, the Middle East, Southeast Asia, Central and South America, for two reasons. One is because they are relatively poor countries, and so they don't have the resources to adapt to climate change damages. And the other one is that they're close to the equator, and so again, they're already in hot climates. And so when you're already in a hot climate and it gets hotter, it has a much more severe impact on that location. And then the top chart is carbon emissions per person per country. So the red ones being high emission countries, United States, Canada, Australia, and the blue being low emissions countries, a lot of them in Africa, the Middle East, Southeast Asia, Central and South America. So it's almost a flip. It's almost an invert, where the countries that are the least responsible for causing the problem are the most vulnerable to its impacts. And so it sets up this really major moral and ethical problem that, we wealthy countries that are the most responsible for the problem are not the ones that are going to bear the brunt of the impacts. So let's go back and look at specifically how in the US we can get our emissions under control. So this is a chart from the EPA looking at emissions in the US by sector. So we got 5 different sectors here. So one thing to look at is that over the past decade, most of these lines are very flat, where emissions have not been changing much at all. There's one exception, is this purple one, which is electricity. And so electricity used to be the #1 source of US greenhouse gas emissions, and now it's actually dropped to #2 because we've been phasing out coal and replacing it with solar, wind, and gas. So now, transportation is the number one source of emissions in the US at 29%. Electricity is number two still at 25%. Industry is 23%. Agriculture is about 10%. Actually, globally, agriculture is much bigger, around 25%. But because in the US we use so much fossil fuels, the fossil fuels kind of swamp out the effects of agriculture. So 10% here, and then commercial residential buildings combined are about 13%. So let's look at each category. But generally, from a large scale view, our solution that we're aiming for is to basically decarbonize the electric grid and then connect as many of these other sectors to the electric grid as we can so that they're being fueled by clean electricity. So since electricity is kind of the basis of that plan, let's look at electricity first. 25% of our emissions currently. One thing you can do is a carbon tax, which is quite effective at reducing emissions from the electricity sector. Because it takes away the advantage that coal and gas have of not having to pay for their carbon pollution. So already wind and solar are very, very cheap, much cheaper than coal, and in most cases actually already cheaper than gas. But if you make coal and gas pay for their carbon pollution, then wind and solar and other clean sources become much, much cheaper, and that's what gets installed just because that's what the cheap option is. So because it's just kind of making polluters pay for their pollution and then just letting the cheapest clean source win out, it's kind of the most economically efficient way to decarbonize the electricity sector. And so it's preferred by economists because basically it's the overall cheapest way to do it. My group, Citizen Climate Lobby, has a bill introduced to Congress that's a carbon tax bill. So that's one good way to decarbonize the electric grid. Another good way to do it is called a clean electricity standard, which is what Democrats are putting into the infrastructure plan, or at least trying to. It's what the Biden infrastructure plan proposed. So basically the idea is that you just mandate that utilities must get 100% over time, more and more of the electricity from clean sources, but eventually get up to 100%. The Biden administration wants to aim for 100% clean electricity nationwide by 2035. So basically you're just doing that by regulations. And then to make this all viable, because you're going to be using a lot more wind and solar, which are intermittent sources, because the wind's not always blowing, the sun's not always shining. So you want to invest in the grid, have long-range transmission so that you're connecting different regions, because one region might have the wind blowing at a given time where another region doesn't. So you want to be able to shift electricity between them and have a smart grid, things like that, to allow for better transportation of electricity. You want to invest in long duration energy storage so that you can store when it's really sunny, store all that energy in some kind of storage system, and then have it available when at nighttime, for example, when there's no sun shining. So these are things that the Democrats are trying to do in the infrastructure plan. They're trying to invest in these things. So then the biggest sector right now is transportation. And actually in California, I believe we're about 40% of our emissions are from transportation because we drive a lot and because we have pretty clean electricity. So this is a really important one for California specifically. Here, carbon taxes aren't super effective because, for example, if you had a modest carbon tax, gasoline prices might go up from $3 a gallon to $3.50 a gallon, which is, it's enough to make people a little more conscious of their amount of fuel that they're using, but not enough to create like a big transition to clean transportation. So you need to do other things. So one thing you do is fuel efficiency standards. In the US, we have these things called CAFE standards, which tells automakers basically how fuel efficient their average fleet has to be. And then you make that fuel efficiency go up and up and up over time, so it gets cleaner and cleaner. Another thing you can do is zero emissions vehicle mandates, which California and Massachusetts have now mandates that by 2035, 100% of new vehicle sales will have to be zero emissions, which basically means electric cars. Actually, Washington is about to pass this up. Their state legislature just passed a bill for 100% zero emissions vehicles by 2030, and the governor will be signing that soon. So they're even more aggressive than we are. Good for Washington. To make that feasible, then you have to have much more EV charging so that everybody will actually be able to charge up their cars. So again, that's something that Biden and the Democrats are trying to do in the infrastructure package that's happening. You need more investment in public transportation so that people don't have to drive as much. Again, something that's in the infrastructure package. You want to invest in rail so that people can use that option, preferably more than flying or locally instead of driving. And then you need for some challenging applications like air travel or like ships transporting lots of stuff over oceans. Electrification is not a very good option there because batteries are heavy. And so you want other options like biofuels or green hydrogen, where the hydrogen is obtained through electrolysis using clean electricity. So you need to invest in the research and development of those options. So again, most of the stuff Democrats are trying to do in the infrastructure package. So hopefully we have high hopes for that infrastructure package that's coming. So the next big sector for emissions is industry, which is basically all the stuff that we make. So manufacturing, construction, cement production is actually a big one. 5% of emissions globally are from cement production. So to address these, again, we need to just substitute as much of the fossil fuels being used as we can with other options, be it electricity or hydrogen, green hydrogen, or biomass. So again, a carbon tax would help somewhat in this sector because, again, you're taking away that advantage of fossil fuels and not having to pay for their pollution. But we still need alternatives to be available. So that's why you have to invest in research and other technologies. You can also do it with standard regulations, basically just tell the industry like you have to shift to other non-fossil fuel sources. There are some important specific applications. It turns out there are a lot of these things called orphan wells, which is like when an oil company drills a new well and then abandons it. So because it's abandoned, they call it an orphan well because, you know, being abandoned, it's not the nicest name, but in any case, there's estimated between like 2 and 3 million of these orphan wells across the country that are leaking, in many cases, leaking methane into the atmosphere. And methane is a very powerful greenhouse gas because they weren't capped like they should have been when they were abandoned. And so we need to regulate that and make sure those wells get capped. The nice thing is that that work can be done by the same workers who installed the wells, and so it's work for that industry that's going to be impacted by shifting away from fossil fuels. It gives those workers an opportunity for good jobs. And then refrigerants and cooling systems historically have used these fluorinated gases that are super powerful greenhouse gases. So we're actually making progress already regulating those and shifting away from those to cleaner options for refrigeration and cooling. So that's progress that's being made already. And then the last two, buildings and agriculture. Carbon tax is not super effective here, somewhat effective, particularly in phasing out gas hookups for buildings. But for the most part, we need to at least have complementary policies or other policies. So one thing we can do is electric building codes and appliance standards, basically saying that buildings have to be and appliances have to be powered by electricity and not fossil fuels. And so in building codes, basically, you're mandating that's the case. A lot of cities are starting to do this, especially in California. 40 cities in California have banned gas hookups in new buildings. So that basically requires that these buildings have electric appliances and therefore smaller carbon footprints. However, there are some states pushing back against this. Arizona, Tennessee, Oklahoma, and Louisiana have actually banned gas bans. So they're telling the cities in those states, you cannot ban these gas hookups the way cities in California are doing. So it's creating this battle between, regions that are trying to phase out these gas hookups, which against states where they're trying to protect the fossil fuel industry. So it'd be nice if the federal government would step in and kind of resolve that fight. And then we talked about improving forest management so that we don't have as much of an issue of trees being burned and releasing carbon to the atmosphere. We can also expand forests with afforestation and reforestation. Although, again, that is a challenge. We have wildfires getting bigger and bigger. You plant new trees, then, maybe they get burned in a wildfire. So it's a challenge to expand forests when you're getting worse and worse wildfires due to climate change. Agriculture, there's actually promising climate change solution through, we call it regenerative agriculture, which is doing methods that will store carbon in the soil. So for example, no-till farming, doing a rotation of crops so that carbon gets sequestered in the soil. And so that by doing farming, we're actually removing carbon from the atmosphere. It actually tends to improve crop yields too and make farms more profitable. The challenge is getting farmers who have been doing the same practices for generations to shift to these new practices. So we need to incentivize that to happen so that we can make agriculture part of the solution of climate change. So there is kind of a little bit of an equity and economic problem when we do these solutions that make fossil fuels more expensive. So this is a chart that shows kind of the increase in annual energy costs for each household in each income bracket, from the poorest to the wealthiest 20% income brackets, for a fairly high carbon tax. But the same principle will apply if you do regulations, and that makes energy prices go up. So you see that for higher income brackets, the cost ends up being higher because basically the wealthier you are, the more stuff you buy, the more you travel, so the bigger your carbon footprint is. And so therefore, the more a carbon tax will cost you. So that makes sense. That's fair. You're paying for your pollution. But the problem is that, so the poorest 20% of households in America, after taxes and everything, end up making about $36,000. And the wealthiest make about $230,000. So if you're making $36,000 and you're hit with almost $1,000 in increased energy costs per year, that is very difficult to afford. Whereas if you're making $230,000 a year and you have to pay an extra $2,000, that's not such a big deal. It's a smaller fraction of your income. And so the problem is, we do these policies that will raise energy prices. It actually has a disproportionately large impact on poorer households, and we already have an income inequality problem in the United States. So one way to avoid this, my group Citizens Climate Lobby, in the bill that we proposed to Congress, we just take all this revenue that's generated from the carbon tax and we send it all back equally to individuals so that everybody's getting an equally sized regular dividend check. And so if you do that, the dividend check looks something like this at this level. So now you can see that lower income households, the dividend check is higher than their increased energy costs. And so it ends up looking like this, where lower income households actually get a net income out of this revenue, we call it a revenue neutral carbon tax. And the higher income households are the ones who have to foot the bill because they have the larger carbon footprint. However, if a higher income household wanted to, for example, get a Tesla, charge it up with solar panels on their roof, make their home more energy efficient, they too could lower their carbon footprints and then pay less in carbon taxes, and they could potentially generate a net income as a result. And that's kind of the idea, is that with carbon pricing, you're making polluters pay for their pollution, but also it's to give everybody an incentive, a financial incentive to reduce their carbon footprints. And so, it's great if wealthy households want to do that and reduce their carbon footprint and, benefit economically. That's great. In the meantime, the important thing is that they're lowering their carbon footprint. And we're doing it in a way that actually addresses our income inequality problem and generates a net income for lower income households. So you're not solving the problem on the backs of poorer households. So there was just recently a nice report by this group. It's actually in San Francisco, called Energy Innovation, Policy, and Technology. So they were putting together sort of a plan for the US to get to net zero emissions by 2050, which is close to our share of the 1.5 degrees Celsius Paris Agreement target. So the good news is, first, they were able to put together kind of a way for the US to get our emissions down to zero by 2050. So that's good. And it was basically the same approach of decarbonizing the grid and then electrifying everything and connecting it to that clean grid. So they were able to make it work out in their model, and then looked at the economic impacts, what it would look like. And so overall, the cumulative investment to make that happen would be $4 trillion by 2050. It's cumulative because they're comparing it to kind of a business as usual scenario, because power plants, appliances, vehicles, everything has a set lifetime. And so once it reaches the end of that lifetime, you have to replace it. So you can replace it with fossil fuel equivalents, or you can replace it with a clean energy equivalent. And so basically the additional cost to switch to the clean energy, plus maybe do it faster so you get emissions down faster, the increased cost is $4 trillion by 2050. And as a result, they estimated you would create 3 to 5 million new jobs, because clean energy tends to be more jobs intensive than fossil fuels, because fossil fuels have been around for a long time and they're very automated at this point. So it doesn't take very many jobs to extract fossil fuels, whereas it takes a lot more jobs to, for example, install solar panels or wind turbines. And so you create a lot more jobs. Because you're creating jobs, you're then giving people a lot more income, which they then spend in the economy. So it creates a boost to the economy. So in this report, they estimated that it would increase GDP by 2.6% nationwide. So you're making $20 trillion for the economy by 2050, which is 5 times what the initial investment would be. So basically, you're actually benefiting the economy. This is somewhat questionable because there's been other economic modeling showing that climate policies are generally pretty economic neutral, directly economically neutral overall. They don't, basically the increased GDP is kind of offset by the upfront costs, but the important thing is that it's not a negative to the economy. So it's either neutral or positive for the economy to make these investments. And that's the direct economic effect. On top of that, there are the effects of the decreased air pollution because you're phasing out fossil fuels, which have the air pollutants we talked about. So as a result, they estimated by 2050, you would avoid about 1 million premature deaths. In total, in 2050, you would have 2 million fewer asthma attacks per year and 6.5 million fewer lost work days per year. I put an asterisk because that's probably an underestimate, which we'll see in the next slide. And then, of course, you're reducing all these climate disasters associated with worse wildfires, floods, heat waves, droughts, hurricanes. So basically, you're creating a bunch of new jobs. You're maybe directly benefiting the economy. You're definitely indirectly benefiting the economy because you have fewer sick people. You have better life outcomes for people because they're not breathing all this polluted air. And you have fewer climate disasters that you have to pay for and suffer from. So it's kind of a win-win-win situation. And then on top of that, the air pollution effects may be even greater. So there's a scientist, Drew Shindell, who used to do really good climate modeling, and he shifted his focus to air pollution modeling. And he's on the verge of publishing a paper that he testified to Congress about a couple months ago. And his results are that over the next 50 years, if we meet the Paris target of 2 degrees, then the US will prevent about 4.5 million premature deaths over the next 50 years. 3.5 million hospitalizations and emergency room visits, avoid 300 million lost work days. If you add all that up, the economic effects, you're saving over $700 billion per year just from improved health and labor, which is more than the investment cost of making this energy transition just by itself. So just by phasing out the air pollution associated with fossil fuels, that more than pays for installing the clean energy in the first place. So if it's a win-win-win, if you're creating jobs, probably benefiting the economy directly, definitely benefiting the economy indirectly, creating cleaner air, healthier people, fewer kids with asthma, avoiding all these climate damages, then the question is, why the heck aren't we doing this already? So the answer is not very satisfying, but it's basically fossil fuel companies have a lot of money. They're some of the most profitable companies in the world. And they spend a lot of money on giving donations to politicians in the United States. So they have a lot of influence over our policymaking. And then, of course, we also have conservative media that have polarized the issue of climate change. Like we saw that example of Tucker Carlson polarizing the wildfires earlier in the slides. And then there was a more recent case of Texas blackouts, which I'm sure everybody remembers. Texas basically froze over. All of their energy infrastructure froze over, natural gas pipelines, natural gas plants, wind turbines. And so they had blackouts. And while this was happening, this 3-day period on Fox News, they had 128 examples, 128 times where they blamed those blackouts on the Green New Deal or on wind energy. And at the time, Texas, the power grid, they were expecting 90% of the energy to come from fossil fuels and a little bit of nuclear, and then 10% they were relying on wind. So basically 10% of the problem was wind turbines and 90% was fossil fuels. And nevertheless, Fox News blamed the Green New Deal, which obviously Texas does not have a Green New Deal, that should go without saying, and they blamed wind turbines, which were 10% of the problem. Which averages out to once every half hour for 3 consecutive days. And so, that's kind of the clearest example you can have of the issue being polarized and really just not accurately conveying the scientific evidence and the reality of what's happening. And so that's a real challenge that we face, is overcoming the power and influence of fossil fuel companies and the kind of nonstop pro fossil fuel propaganda coming from these conservative media outlets. So I'll stop now with trying to figure out what we can all do to overcome that opposition. And number one thing we can do is vote. Vote for politicians who make climate change a priority. I hate to be polarizing, but right now that is Democrats. Like, Democrats are trying to solve a climate crisis, and right now Republicans, like, there is no Republican in Congress that is willing to do anything close to the scale of climate policy that we need to happen. So that's unfortunately the reality right now. I hope it changes very much. I hope the Republican Party will start to get behind some serious climate solutions. Another major thing you can do is join a grassroots climate advocacy group. There are lots of good ones. Like I mentioned, I'm in Citizens Climate Lobby, which does a lot of good stuff. Just a couple of weeks ago, my group in Sacramento had a meeting with our member of Congress's chief of staff to lobby her to try to get support for a carbon tax and learn more about what she's endorsing in terms of climate change policy in Congress. The Sunrise Movement is doing great stuff. 350.org, Sierra Club. There's all kinds of great groups. So if you can, get engaged with these groups, because they will get you directly influencing the members of Congress who are making these decisions about climate policy. And then, of course, there's individual action. You can reduce your own personal carbon footprint by eating less meats, especially beef, which is a very, very carbon intensive food. So the less beef you eat, the better you are. The less meat you eat, the smaller your carbon footprint is. Use less energy at home, burn less gasoline, just use less fossil fuels in general, however you can. Drive less, get a more fuel efficient car, use public transportation. But individual action, you're only affecting your own carbon footprint, whereas collective action, we're affecting everybody's carbon footprint. So collective action is very, very, very important, which is why we want to get engaged in the political system. And actually, the idea when we're passing these climate policies is to create the incentive for everybody to reduce their carbon footprint. So if you're reducing your own personal carbon footprint, that's great. You're ahead of the game, but we need to get these policies in place to make everybody follow suit so that we can get our emissions down to zero and limit climate change damages. So that's it. I'm going to stop talking now and we can kind of open it up for questions. That's my email. You can shoot me an email if you want and you have any questions, and that's my Twitter too.
Fantastic. Thank you, Dana. That's great. So everyone, a nice stretch and a big breath, and then please feel free to raise your hand or speak out a question with your voice, or put an idea in the chat to respond and to probe a little further here. That's great. And while people are doing that, Dana, I do have a question for you. Of the 4 bills that the Citizens Climate Lobby is backing, plus their own, I guess, or I don't know, they're backing 4, and then there's the Energy Innovation Act, I guess is like a 5th. Would you, if students want to be a part of advocating for those, would you say that they're all equally good, or are you saying, would you suggest that one is like, it's a better idea to advocate for one at a time? Are they all coming up at the same time? Like, how's that work?
Yeah, so the Energy Innovation and Carbon Dividend Act is the carbon pricing, the revenue neutral carbon pricing bill that I talked about. So that's the one that would kind of hit all the entire economy and take away that advantage that fossil fuels have of not paying for their carbon pollution. So that's kind of CCL's main bill. That's kind of the big one where we're trying to get a carbon price in place to kind of reduce emissions economy wide. So that's the big one. And then CCL also endorses a few smaller bills. The idea is that the ones that they endorse have some bipartisan support, so they have a better chance of passing in Congress. So the things like helping coal communities as coal power gets phased out, we're trying to help those coal communities get jobs in other areas. They've endorsed a bill to do some research into battery storage, things like that. So they're smaller solutions, but they're important solutions and solutions that actually have a chance, and policies that have a chance of passing in Congress. And so we're trying to kind of help that along because they would make a little bit of a difference and actually could become law. So
even Feinstein's, you guys think Feinstein's is like putting forward what you want, what your group would want?
Which one was that?
It's Feinstein and Coons, the Climate Action Rebate Act. Is that a good one too?
I don't know the details on that one specifically.
All right. But that's good to know that you guys have the one big one, and then the others you think will be generally
Right.
supportive, because we've got students ready to do this at 8:30. We're gonna lean on all this stuff and make it happen with the power hour.
So Kunlin had a question about saying Heidegger worries that mankind can only solve technical problems with technology. Do you think that using new technology is the most effective way to solve climate problems?
I mean, I think the way our society is built right now, that's kind of the option we have. Because we've got this standard of living that we're accustomed to. We're in a capitalist society, and that's not going to change anytime soon. So, kind of our option is we need to maintain the standard of living that we have, so that people don't revolt against any climate policies that we enact. And so, in order to maintain that standard of living, we need to maintain energy use close to current levels. We can improve it with energy efficiency. But yeah, we solutions generally need to be technologically based. I mean, there are some solutions that are kind of natural carbon sequestration, like planting more trees, storing more carbon in soil. So those are helpful solutions that aren't technology based, but they can't address the scale of carbon that we have put in the atmosphere. And so I think most of the solutions kind of have to be technology based, just on based on what our society is built and where we're at right now.
Hi, Dana. Thank you so much for your talk again. I just had one question. In your line of work, you undoubtedly come across a lot of people who, make you want to like put a hand to your head, and what keeps you grounded, and what keeps you not wanting to just like flip the table and say, whatever, I'm done with this whole thing, like in a more, yeah, what keeps you from doing that?
Yeah, so I try to bear in mind that, I mean, there's some good polling by another group at Yale called Yale Climate Communications. They group it into, they call it Six Americas, where they group us between basically denialists and concerned and alarmed and different categories. And so the people who are really just rejecting the science are a very small proportion. It's something like 10% or so of Americans, whereas everybody else is somewhere between like cautious and alarmed. And the number who are alarmed is increasing. So we're moving in the right direction, and the number of people who just outright reject the science is fairly small. And so I try not to waste too much time, because we can solve the problem with the majority of people without worrying about this small minority of climate deniers. And then seeing the progress happening in Congress right now, also and for the Biden administration, also makes me very optimistic, because it's looking good. Like there's going to be some good stuff in the infrastructure package for the climate, and there were the great climate executive orders that I mentioned. So after decades of just frustrating pounding your head against the wall, we're finally seeing some progress. And so it's nice to see us moving in the right direction. So that kind of helps me too, is don't worry about the small fraction of climate deniers, and just focus on the progress we're making and accelerating that progress.
Thank you.
Oh yeah. So the question about the seaweed in cattle feed reducing methane from cow burps. So yeah, that's at UC Davis, which is one of my alma maters, and it's very cool. So basically cattle, because they're ruminants, when they digest their food, they burp and they spew a lot of methane into the atmosphere from their burps. And then there's actually a second problem with livestock, is that they take a lot of land, and a lot of land gets converted from forest and other vegetation to prairie for grassland for them to graze on. And that's bad for carbon sequestration too. But at least their diets, yeah, there is some good research that if you put a certain type of seaweed into their diet, it significantly reduces the amount of methane in their burps. The downside with that is, one, it doesn't solve that land use change problem. And the feed also only applies when they're in these large industrial farms, feedlots, when they're in feedlots, and not when they're kind of out on the grassland eating grass, because then you can't give them the seaweed if they're eating grass. So it's 82%, something like 80% of the burp methane emissions when they're in that specific scenario on the industrial farm eating the feed, but it doesn't address the other problem. So overall, I think it's something like more like a life, like if you look at a cow life cycle methane emissions, it's more like, or this carbon life cycle greenhouse gas emissions, if you count for land use, it's more like 10%, I think it was. So it helps, but really we need to shift away from so much consumption of beef to address that problem. The use of seaweed can help a little bit, but it doesn't help as much as that headline number of 80% makes it sound like it helps.
Or Dana?
Kristen, I have a question. In general, trees are good for the environment. So due to the wildfires that we've been experiencing, do you anticipate that timber companies will begin clear cutting more? I've been seeing more of that happening in Northern California and Oregon. And of course, they've been doing work because of the wildfires and things that have been happening. And the timber prices are sky high right now as well. So do you see that there's going to be, how's the balance going to be struck there? Or is there going to be a balance struck?
Yeah, I mean, hopefully we'll do smart forest management practices and not just clear cutting, because that doesn't necessarily help the wildfires. Like, one big problem we have is that we had this intense drought from 2012 to 2016 that a bunch of trees died. And so we have all these dead trees lying around throughout California, especially in the Sierra Nevadas. And those are really bad for wildfire fuel. And so that's the kind of thing we need to focus on removing, is like there's like 150 million dead trees in the Sierra Nevadas. And the problem is that that's not an economically viable thing for a lumber company to do, because that's not good wood for them. They want new wood. So it's a challenging thing that we have to do this forest management in a smart way. I think I've read some news that Governor Newsom is really doing some good, trying to make some progress on that. And like, one thing we can do is not worry so much about like cutting down the trees, but doing controlled burns. So using that fuel load. So that's a difficult thing to do, because then, if you have a controlled burn, you still have to worry about the air pollution associated with that. And we have a lot more people living on we call it the wildland urban interface, because we also have bad housing policy in California. So it's really expensive to live in cities. And so more people move away from cities and live closer to the forests. And then it makes it harder to control burns because there's a house there.
Right.
So there's always connection between our housing policy and trying to do good forest management and do controlled burns. But we are supposedly trying to do more controlled burns now, which is good, because we need to reduce that fuel load when the conditions are such that we can actually control the wildfires, like in the kind of winter, spring months, as opposed to the wildfires burning in the summer months when we can't control them and they have these huge record wildfires.
Yeah. Okay.
One of the things my Indigenous friends shake their heads at about me and my people is that we do not know how to control the forest as a living being, and we don't know how to make way for things and keep it from becoming, meadow and other sort of transitional things, and just keep it what it is. And so they, I think when I talk to them about wildfires, they laugh, and not maliciously, just because they've done this forever.
Yeah. Native populations were very good at controlled burns and land management, and we kind of displaced them and stopped doing that. And they've been trying to tell us for a long time, you need to do these controlled burns, and finally starting to listen, but we've gotten to a bad point by not listening to them for a long time.
Such a small number of people are left in all the tribes, but they tend to about 70% of all the healthy forests. And if you look down at Wisconsin, or is it Wisconsin, from the top, there's only one green area that's absolutely healthy forest, and that's all Indigenous led. So Indigenous led forestry, I think it's important to mention it in light of our day and in light of our whole turn intention of really looking at who are the leaders here, who are the people that know how to do it, who should we be following. So
I agree.
Great. Well, listen, we're going to wrap up. We're at time. And if anyone wants to stay another minute or two, there are different people here that can stay and field those questions. Thank you so much for coming.